Thank you. So I will share some thoughts and results with you on the durability in harsh aeronautic environments. I guess you know Airbus, your leading aircraft manufacturer, product portfolio from aircraft, helicopter, satellites, secure communication, and so on. And myself, I'm based in our central research organization called Central R&D. Myself, I'm in Ottobrunn-Taufkirchen, which is close to Munich in Germany. So very often when we talk about sensors, the sensing element is quite small, for example, a chip, a MEMS device, but then comes the packaging, housing. To protect it, we need to assemble it somewhere, the connector or the cables. And if we need many, many sensors, then it becomes more and more sometimes messy, at least a difficult installation, and so on. So therefore, the idea of integrating the individual devices in a foil and having only something like a protection layer maybe on that foil, the foil itself, something maybe 100, 200 micrometer thick, and then gluing that onto the aeronautic structure. And that's it. And the question was, is that feasible? Or can we completely forget about that when we think about all the loads we have there, the environmental conditions? So it was just not known at the beginning, and we wanted to investigate it because if that works, it would have quite some benefits. And I will show you just some ideas where these kind of technology could be applicable. For example, temperature monitoring, humidity, pressure, several gases we're interested in measuring, inertial measurement units, airflow, structural health monitoring, corrosion monitoring, active noise control, distributed sensors on the wing, and so different kind of sensors. And then the advantage that what we have is to integrate the electronics and the wiring all in, let's say, in a thin foil that is applied to the, for example, aircraft structure. We started with some, let me see. No, I do it like that. No, okay, doesn't work. Our test structures are like 30 centimeter and 2 long and 2 centimeter wide foil stripes, and at the one end there are the devices. At the right hand side you see a cross section. So we have 100 micrometer thick TPU foil, and then copper tracks. Then we have standard devices, representative standard devices, 900 micrometer thick QFN that is soldered, and 230 micrometer thick SMD device that is soldered on this substrate and then embedded in a TPU layer or a TPU-based globe top. And we have, let's say, SMD, QFN, and a copper meander, and these three devices duplicated on that foil stripe. Now I need to mention a few things regarding composite. So aircraft structures, of course, need to be lightweight. And lightweight material is aluminum. But more and more aluminum gets replaced by a composite because that's even lighter or similar or has better mechanical properties. And what is composite material? CFRP, carbon fiber reinforced plastics. That's carbon fibers which are embedded in epoxy material. Frequently it's cured at 180 degrees Celsius, and then it's a stiff and strong material. And on that, on these structural elements, on these plates, we have placed with an adhesive film our samples, which I have just shown you before. And some of the samples have been painted, some without paint. We see here a few samples, for example, something like 10 centimeters long, so that you get an idea of the size. And then we have here the different foil stripes, that come out of that. So a large number of samples at the right-hand side, you see that some of them have been painted. And now,